Ladies and gentlemen, let's get right into the problems from 1-4 angle measure. Here we have our first figure. We've got a bunch of points, line segments, lines, rays, a lot of angles. Everything is labeled, and we're going to jump right into that first question that they ask us there. Actually, they just say, name the vertex of each angle. So looking at angle 4, if we look at angle 4 is right here. That would be this angle that I'm about to highlight for you there. That's the angle they're looking at. So, which is the vertex of that angle? It's actually going to be point Q. Remember, the vertex is just a single point. So we can write point Q. Moving right along to the next one, angle 7. And angle 7 is right in the middle here of all this confusion. Okay, angle 7, if we highlight it with the yellow highlighter there, that's going to be the angle. And if you can easily see that our vertex is going to be point P. Moving right along to angle number 2, if we just notice it right in there, point R is going to be our vertex. And lastly, angle 1, way up here in the corner, okay, you can easily see that point M will be the vertex of angle 1. Now let's name the sides of each angle. Angle TPQ will be the first one we look at. So I'm going to highlight it just so we can see it. TPQ. And if we notice, if we remember back when talking about the definition of an angle, the sides are actually going to be two rays. So if we start at the vertex, PT will be our first one. Let's go ahead and write that guy out. PT, let's use the right notation. And then PQ will be our two sides of that angle. So now let's look at the second one, which is V and M, and we trace that guy out too. V and M. Again, our two rays will be NV and NM. Now we're going to take a look at angle number 6, and we're going to highlight that guy right here in the middle. But if you notice something not strange or weird about this one, but its sides aren't really raised. They're line segments. That just happens in this figure. Sometimes, depending on the type of figure that you have, they won't be raised. And if you could see, NM are not actually raised. They are line segments, NM and NR, the two sides of that angle. We can move right into angle 3. And we're going to trace that again. Angle 3 is right here. We're going to start at that vertex and go 1 and 2. So the sides, we got two rays again, if you notice. We're going to start with the bottom one, RQ. And then RP. But remember, RP, you can also say RT because it doesn't matter which point you use as the second point. The only one that matters is the vertex. So we can use either RP or RT to name that second ray. Now we need to name an angle with vertex N that appears obtuse. So we want to go ahead and circle and find vertex N. Here it is there. And we want to look for an angle that appears obtuse. Remember, an obtuse angle is one that measures more than 90 degrees but less than 180. And there are actually two options we can look at. We can look at this angle here and also this angle here. So let's go ahead and name both those angles. The first one, the one I highlighted in yellow, I can name angle VNP. And the second one, I can name angle RNM. Next, let's name an angle with vertex Q that appears acute. So we're going to again circle vertex Q, and let's trace an angle. There's only really one we can look at, and we're going to name this guy angle RNM. Now let's name a point in the interior of angle VRQ. So let's trace VRQ. VRQ. I'm just going to highlight the space that would be on the interior, and we can name any point that we see in there. So I'm just going to say we can either name P or T. Now let's look at angle MRT and name a point that's on the exterior. So let's go ahead and highlight again MRT. And I'm going to go ahead and shade in the area that would be on the exterior. That would be the exterior of angle MRT. And we can see that at point S or Q end up on the exterior of angle MRT. Now we need to name a pair of angles that share exactly one point. So there are a few different answers to this one, but I'm just going to look at one of them. I'm going to go ahead and highlight this angle here. Let me highlight them first and then I'll talk about them. And then the second angle I'll highlight is this guy here. We're just going to name them angle number 6 and angle number 8. If you notice, angle number 6 and angle number 8 both share point N. They have the same vertex. And if we were actually to write those names out, are the letters angle M, N, R, and angle V and P, you can see that they only share one point, which is the vertex in both of those angles. Next, we need to name a pair of angles that share more than one point. So again, I'm going to highlight them and then talk about them here in a second. There's more than one answer to this one as well. So I'm going to highlight that angle. And then right next to it, I'm going to highlight that angle there. Okay, the blue angle I'm going to name angle MPR. MPR. And then the next angle, the yellow one, QPR. Sorry, QPR. Again, if you notice, they share more than one point. PR and PR are in both. They share a side, PR. So we've got a brand new figure now. If we look, we've got point F and a bunch of rays coming out of this thing. FG, FL, FK, FH, and FE. And it's telling us that rays FL and FH are angle bisectors. So that means that FL is going to bisect the angle GFK. So and what does that do? That makes these two smaller angles congruent to each other. The same thing happens over here with FH. FH bisects this angle, so I'm going to say that these two are congruent to each other. So they want us to state the measure of each angle and classify it as being right, acute, or obtuse. So GFK will be the first angle that we take a look at. GFK. Oh, I erased it. GFK. And if you notice, this little guy right in here at the very beginning, that means that's a right angle. So we're going to say that this is a 90-degree angle and classify it as right. The next one, LFK, I'm going to highlight LFK is the angle we need to look at next. Now we just said that the big angle, GFK, was 90 degrees. And if that is an angle bisector, that means it's cut in half. So I can write this angle, half of 90 is 45 degrees. This one also is going to be 45 degrees. So LFK would be 45 degrees, and by definition, that's going to be an acute angle. Before we go on to the next one, we have to take notice that GFE, that is on one line. If you remember, one line, the measure for a line is 180 degrees. So if this side is 90, that means this side will also be 90, because 90 plus 90 is 180 degrees. If these two are cut in half, that also means that this is 45 degrees and this is 45 degrees. Those two angles will each be 45 degrees. Now let's take a look at angle GFH. I'm going to highlight GFH. If you notice, that's 45, 45, and 45 degrees, which would give us a total of 135 degrees, and that's going to be an obtuse angle. The last angle we're going to take a look at is angle EFH. And again, we've already measured that. That's going to be 45 degrees. Since it is less than 90, it's going to be an acute angle. We're going to actually measure a few angles now with the protractor, and the first one is going to be angle CZD. So if we take CZD, and since we started on this side of the protractor, we're going to use the outer numbers, and if we look very carefully, that's probably going to be, actually no, if we're going to follow all the way across to 150 degrees, and we need to classify it, and that would be an obtuse angle. The next angle that we're going to look at is angle CZE. So here we are again, CZE. And since this one over here is a 90-degree angle, this one's also going to be a 90-degree angle. That's 90 degrees, which makes it a right angle. The last angle we're going to measure is angle DZX. Here we are, DZX. And since we started on this side here with XZD, which is the same as DZX, we're going to use the inside numbers. And that's going to be a 30-degree angle, and that's going to be an acute angle. Finally, we need to find the measure of angle BHC and the measure of angle DJE if angle BHC is congruent to angle DJE. And we know the measure of angle BHC is equal to 4x plus 5, and the measure of angle DJE is equal to 3x plus 30. Well, since we know that the angle BHC is congruent to angle DJE, we can say that the measure of angle BHC is equal to the measure of angle DJE. And since we know what those are, we can just plug those in. 4x plus 5 is equal to 3x plus 30. And now all we have to do is solve for x. So I'm going to subtract 3x from both sides. On the left side of the equation, I'm left with x plus 5 equals 30. I'm going to subtract 5 from both sides. And on this side, I'm left with x equals 25. But that's not what they're asking for. They want us to find the measure of BHC and DJE. So let's go ahead and start with BHC. We can plug that back into BHC is equal to 4x plus 5. We're going to plug that 25 back into x. And now we've got 100 plus 5, which will give us a measurement of 105 degrees. Now, we don't have to plug that back into DJE because we know that those two things are equal to each other, so we can just say that the measure of angle DJE is also equal to 105. Well, that's all the problems we have for 1-4. Again, if you have any questions, please do not be afraid to ask. I'll see you guys in class.